Swayam Prabha. Digital India. Educated India.
Hello, I welcome you all in this course on refrigeration and air conditioning. Today we will continue our discussions on indoor environment health. Today we will discuss the ventilation, room air movement, and we will discuss about the air filters as well. Now in ventilation there are two types of ventilation. One is natural ventilation and forced ventilation. Forced ventilation, right? Now, in natural ventilation, no external energy is required. As we discussed earlier, due to stack effect in the building, when inside occupancy is hot, outside is cold, especially in the nights, because in the night, outside is colder than inside. Of course, if you are not sleeping in an air conditioned environment, naturally in a building, inside environment is hotter than the outside environment. In that case what happens, the air can flow in from the bottom of the building and can leave from the top, right. So this is called night ventilation. Otherwise in natural ventilation, the ventilation in the building takes place without any consumption of energy or in a natural manner. It can be through the flow of air over the building envelope. In that case also the ventilation will take place, and natural ventilation can maintain the required amount of air is required for maintaining the indoor environment health. In case of mild weather, if the weather is mild or the climate is mild, in that case even natural ventilation can provide good indoor environment health. But in case of extreme climates, one has to go for forced ventilation systems, and forced ventilation system is definitely you are fixing some fan or either at the exit or at the inlet. So either induced draft will be created in the building or the forced draft will be created in the building, and that is known as forced ventilation. Now flow in the room, flow of air inside the room is also important. Flow and dispersion of air inside the room. Suppose there is a room and air is entering from this side, from any point, from this side, and when air is flowing in the room, then it will also take air, because low pressure may be created here. So air from the surrounding of this jet shall be mixed with this air. This is known as entrained flow or flow entrainment, and this mixing will definitely affect the properties of this air. That is known as entrained flow. Another type of ventilation is displacement ventilation. In displacement ventilation, the new air enters from this side and it displaces entire air in the room from the other side, or air in this room is displaced, and in ideal case it should be a piston effect. It is something like a piston is moving in this direction and displacing the air. That is the ideal case, but it does not happen in actual practice. But most of the air is displaced, 90% or 80% of the air is displaced, and there are displacement devices, ventilation devices are available in market. Okay, and if the air is coming to the room through these devices, there is a parallel flow stream, and providing a pistonic effect, it displaces air inside the room. So there are two types of flows in a room. One is entrainment flow, another is displacement flow. And this flow is always controlled by the fans. In a fan, we all know there is a fan total pressure FTP, and FTP is proportional to rho d square n square. D is the diameter of the fan, n is the RPM. So, suppose if we change RPM of the fan, the total pressure, fan total pressure will reduce square root of this. It is not directly proportional. Similarly, discharge, how it is going to affect the discharge? Discharge is, so if I reduce the RPM, the discharge will be proportionally reduced, or if I increase the RPM, discharge will be proportionately increased. Pressure will increase in square of the RPM. So, rise in pressure, fan total pressure will be sharper, percentage rise in fan total pressure will be sharper than the percentage rise in discharge, and power consumed by the fan is proportional to Q delta P. So, it is going to be d cube n into rho d square n square, and so the energy consumed by the fan is proportional to rho d raised to power 5 n raised to power 3. So, you can imagine when we suppose we increase by some percentage the RPM of the fan, the variation in flow rate will be linear, then this is going to be a sort of square of this, square of RPM, and this is of the cube of the power consumption will be cube of RPM. This information is required because often there is variation in fan RPM due to variety of reasons. And second thing is normally in the fan, suppose there is a centrifugal fan. In a centrifugal fan, normally backward vane type of fans are used, because if there is a flow variation in the flow, power consumption will not be very significant. Enhancement in power consumption will not be significant, and efficiency of the backward vane type of centrifugal fan is approximately 80%. So, efficiency is also high, and if you deviate from optimum design conditions, the change in other parameters is not significant. So, that is why most of the cases in centrifugal fans, the backward vane type of system is used, unless very high pressure ratio is required. If very high pressure ratio is required, then in that case forward vane type of fans are used. When we talk about ventilation, ventilation rate becomes important, because we have to quantify the ventilation, how much ventilation is taking place. So, in order to quantify the ventilation, there is a term air exchange rate. Air exchange rate is denoted by I, is equal to air entering to the room, ventilation air entering to the room per hour divided by the volume of the room. It means per hour or per second, I mean it is a time unit. So, how much volumes of the air have entered the room in form of ventilation, right? And another term is nominal exchange rate. In nominal exchange rate, total air is not considered, but total outside air is considered. That is known as nominal exchange rate. After that comes the time constant. Time constant is denoted by tau is equal to inverse of I or V by Q, and the unit can be second or hour, whatever unit we are using. So, that is going to be the time constant. So, these are certain things which quantify the ventilation in the building. Now, ventilation in a healthcare unit, because indoor environment health in healthcare unit is very important. So, if proper ventilation is not maintained in a healthcare unit, In that case, severe infection can be caused by the patients, and sometimes it can be fatal also. You must have heard or you must have read in the newspaper, many of the patients die due to post-surgery infections. Now, in a healthcare unit, some filters are provided. Mainly infection takes place through bacteria or virus in healthcare units. So, there certain filters are provided. One of the filter is HEPA, high efficiency particulate air filter. If we use 3 layers of this filter, even we can prevent the entry of the bacteria in the confined space. Normally the bacteria size is approximately 1 micron, and that is the movement of this bacteria is prevented by HEPA filters. So, they are commonly used in the bypass surgery room or the surgery where which is very prone to the infection. Now, another type of filter is used is ULPA, ultra low particulate air filters. So, these filters are high end filters, and they are proposed to be used in the healthcare units. In a surgical room, high air exchange rate has to be maintained. In the intensive care unit of the hospital where or surgical room of the hospital where bypass surgery or critical surgery takes place, laminar flow benches are used. In laminar flow benches, the patient is laid and air comes from one side and the flow of air is laminar flow. And this laminar flow passes over the body of the patient. The velocity is quite high. It can go up to, let us say, 1.8 meter per second. And on this side, there is a layer of high efficiency particulate air filter. So, all the air which is coming to the laminar flow bench is coming through HEPA filter. Now, the property of laminar flow is that there is no cross transfer of the movement from one layer to the another layer. Suppose one virus or bacteria is in one layer, it will continue to be in that layer, it will not spread in the room and it will pass from other side. Now, these type of benches are used for preventing post surgery and during surgery infections in the patient. In addition to this, the exhaust and inlet in the hospital has to be taken care of. The exhaust of air to the atmosphere and inlet of air for the air conditioning purpose. There should not be any waste disposal side close to the inlet because this may contaminate the air. For this reason, it is always recommended that inlet should be approximately 1.8 meter over the ground level, and if inlet is at the rooftop, it should be approximately 0.59 meters above the roof level. In addition to this, in hospitals, personal ventilation is also provided. In general wards or in ICUs also, the personal ventilation is, suppose patient is lying on the bed, the fresh air will come from the pillow and it will envelop the face of the patient. So, this envelope is created throughout on the face of the patient with the fresh air and which is definitely on a slightly higher pressure, so that outside air is not inhaled by the patient. This is known as personal ventilation, and it is becoming very popular in hospitals, even in offices. In some of the countries, in offices are normally, you will find normally there is a big hall in the companies and there are cubicles and people are sitting in the cubicles. So, instead of cooling the entire hall, the individual is provided some fresh air, or the individual is surrounded by the fresh air, and that is known as personal ventilation. And this type of ventilation is becoming very popular because it is cost effective. Less air, the quality of the less air has to be maintained and it is easy to operate. So, but these things are done only to maintain the indoor environment health, and therefore ventilation is very critical. If proper ventilation is done, definitely the good quality of environment health, indoor environment can be maintained. One more ventilation type of ventilation which is frequently being used, that is ventilation in the tunnels, because nowadays with the development of the countries or development in our country, more and more tunnels are being dug for the rapid transportation or for metro transportation. Now ventilation of these tunnels is critical. We cannot put a fan here or something fan here or fan at certain intervals. Now in these tunnels shafts are provided, they are openings, they are known as shafts, and with these shafts, in these shafts fans are provided either to supply air to the tunnel or take away air from the tunnel, and these shafts are provided after a certain interval in the tunnels. Sometimes through the supply shaft a ducting is also done up to a certain extent so that the air is uniformly spread. If tunnel is not very long, jet fans are used. Jet fans are the fans which throw the jet of the air with very high velocity. So jet fans you must have seen in the parkings of shopping malls where these jet fans are provided. This function of this jet fan is to remove the smoke in case of emergency. So in case of emergency, these jet fans can be used for removing the smoke as well. So here the function of the jet fan is, in this case, is only the circulation of air. So nowadays tunnel ventilation is also becoming popular, but first and the foremost thing in indoor environment health is filters. Some of the filters we have already discussed. Now there are certain type of filters which can be classified as classification of the filters, shape of the filter. It can be in the form of a panel, it can be in the form of a extended surface. So as per the shape of the filter they can be classified. Coating of the filter, coating mean it is a dry type filter or some viscous coating. Sometimes viscous coating is done in order to remove the particles. Viscous type or dry type filters. Operating life, once use or use and throw type or disposable type or disposable, or it is a recyclable or renewable. And efficiency of the filter, high efficiency, low efficiency and medium efficiency. This is how the filters are classified. And mechanism is, first is direct interception. The air stream is coming to the filter, direct interception of the air, and air goes out, particles will be retained here. But sometimes results of these filters are misleading, or nowadays it is not used, but not much used, because if some of the particles are heavy, then percentage wise we can say this much of percent of dust or contaminant we have filtered through using this filter, but in actual practice most of the small particles will pass through this filter and it will not be that effective. So that is, one is direct interception type of filters. Now types of filters. Now types of filters. They are dry type of filters. The pressure drop across the dry pipe filter is 1 to 10 to 60 Pascal, and with this pressure drop the filter surface remains dry. Another type of filter is viscous filter. In viscous filter, viscous coating is made on the filter surface and dust particles they stick to the viscous coating on the viscous filter. Third type is automatic type of filter. In automatic type of filter, there are two rollers, and When the air is passing over the filter, the rollers keeps on moving, and after a particular time, the part of the this filter which is coming into the air, which is coming into the contact with the air, it keeps on changing. So automatic type of filters, in automatic type of filters, the effectiveness of filtering is more, because every time after a certain time interval, this a filter, the part of the filter will be shifted, because these rollers are moving with a certain velocity, and that is why we get a better quality of filtering in this type of automatic filters. Ultraviolet filters are also there. Ultraviolet. Ultraviolet filters are used for bioaerosols, because bioaerosols are almost of the same size. Normally ultraviolet rays are used for killing the bacteria. So these type of filters this can be also used for filtering. Another type of filter are adsorption filter. Now absorption, there is a difference between absorption and adsorption. Absorption means the absorption of solvent in the solute, that is absorption. Refrigeration you must have, we have discussed, amply discussed. Now adsorption is absorption only on the surface. Solute does not enter inside, it remains only on the surface. Like if you dip a chalk in ink, the ink will remain, if you break the chalk, inside will remain white. Ink will be strained only, or ink will be straining only outside the chalk. So this is adsorption process. Now it is becoming very popular, and with the help of activated carbons are used for adsorption filters. Wet filters are also there. Wet filters, they are like scrubbers and washers. But the wet filters are not recommended for the solid particles, right? So for solid, otherwise wet filters and scrubbers and air washers. They are wet filters are using for cleaning the air. Now testing method. The testing method is, first is dust spot test, testing methods. Now first is dust spot test. In dust spot test, this is the testing of filters. So if there is a filter and air is blown over the filter on upstream side and downstream side. On the upstream side, on drivestream side, on a filter cloth, the strains are seen, whether if and they are optically analyzed. If there is an improvement in the strains, I mean the strains are lesser, it means the particles have been filtered from this filter, and that shows, and through this process we can find the efficiency of a filter. Now another test which is very popular is methylene blue test. Methylene blue has particles which are in size and shape very close to the particles of dust, which are very close to the particles of dust. So methylene blue is passed over the filters, and filtering of methylene blue particles is noted, and that is how the efficiency or effectiveness of a filter is decided. And that is all for the testing method of filters. So in order to maintain the indoor environment health, choice of proper filter is very important. So a proper appropriate filter should be used in order to indoor health environment. That is first thing. And the second thing is proper ventilation should be there in the room or in the occupancy. And in order to have proper ventilation and proper diffusion of air, not only ventilation, diffusion is the distribution of air in the room. So, there should be a proper diffusion also in the room. With the help of these tools, the indoor air environment health can be maintained. This is all for today. Thank you very much.